Okay, so we're still solving for unknowns, right? Our x's are unknown. We have, looks like 3 in here. But we're going to simplify the question before we solve it because there's a lot of stuff we need to kind of put together. So the very first step to simplifying is, let's recognize that there is a left side again and a right side. And that's going to come in handy for when we go to check our answer, right? The left side needs to equal the right side. So it's kind of like balancing a scale. We want to collect all of our like terms. So 3x, positive x, and technically positive 7x are all like terms. Negative 2, 5, and negative 3 are all like terms. Okay, so I'm going to collect all the like terms on the left side to start, and then I'm going to collect all the like terms on the right. So 3x plus x will give me 4x, and I still have minus 2. Okay, so the two blues combine to become 4, and the negative 2 stays as negative 2. On the right side, 5 minus 3 is 2 plus 7x. So the two constants combine to be positive 2, and my blue stayed at 7x. Now you said you're used to variable working on the left side, right? Mm-hmm. So I'm going to move...
But it's okay.
Yeah? Okay, so let's do it the other way just so you kind of get used to it. I'm going to move the 4x over to this side. So this 2 will still stay negative. It doesn't change. And we're going to get 2 plus 7x minus 4x. So now, our red guy's over here, and this guy's a red guy. Those are like terms. And these two blue guys are now on the same side. Because they're on the same side, we can collect like terms. So we have negative 2 equals 2. And 7x minus 4x will give us 3x, okay? So we're now left with only one blue term, but we still have two red terms. We need those to become simplified. So I'm going to move this 2 to the other side. Exactly.
Negative 2.
So we get negative 2 minus 2 equals 3x. So that's a blue and a red. Negative 2 minus 2 is negative 4 equals 3x. Okay, so now we're left with our terms here. We have a blue term and a red term. I can't simplify any farther. And they're on opposite sides of the equation. But the goal is to get x by itself. So I still need to move this 3 to the other side. And when I do that, I have to divide by 3. So my answer becomes negative 4 over 3 equals x. Or, I should move the or over. As a decimal, that's 1.33 or just 1.3 repeated, right? Well, I want to check this answer. So I'm going to take my original equation for the check here. So let's write this in, check. The original equation read 3x minus 2 plus x is equal to 5 plus 7x minus 3. Now, what I'm going to do here is I'm going to check two different ways because I've represented my answer in two different ways. Okay, let's see if I can do this. I have one where it's a decimal, and I have another example where it's a fraction. So I'm going to split this and show you how rounding as a decimal is a little more inaccurate when I check. Okay, so I'm going to split this down the middle here, hopefully. So on the one side, I'm going to plug in for x, and I'll highlight x. Actually, let's write it like this. So we're going to write 3x minus 2 plus x equals 5 plus 7x minus 3. And in the one case, what we're going to do is for each of the x's, we're going to replace it with the decimal we have above. Okay? Still the same idea, same equation, 3x minus 2 plus x equals 5 plus 7x minus 3. In this version, what we're going to do is we're actually going to replace it with our fraction, where we'll have to remember our fraction rules. But the upside of this is this will give us a very accurate answer. Okay, so I know it's getting a little confusing here because we split them, but here's the idea. In this one, we have 3, and I'm going to just change the color, times 1.33, right? That was the value we had, minus 2 plus 1.33 is equal to 5 plus 7 times 1.33 minus 3. I'm going to deal with this all first. Okay? Remember, the goal is to get the left side to equal the right side. Okay? So, with my calculator, we're going to solve this. We have, I'm just going to check what's that. So, like we said with our calculator, we're going to solve this. 3 times 1.33, 3.99. I'm going to leave them as decimals, okay? So this is 3.99 minus 2 plus 1.33 is equal to 5. And then we have to do 7 times 1.33. 7 times 1.33. 9.31. 9.31 minus 3. Now all we do is equate these numbers together with our calculator and equate these numbers together and see if they're equal. Okay? And that'll kind of be our check. So on this side we have 3.99 minus 2 plus 1.33. Oh shoot, did I make an error here? Yes, it's supposed to be a negative value. That's okay. So
change number into
that needs to be a negative. This needs to be a negative. And this guy here needs to be a negative because we multiplied. Okay, sorry. That's okay. So we have our calculator out. Try that again. We have 3.99 when it's negative, minus 2 minus 1.33. Negative 7.23. 23 or 32?
2, 3.
Was it? Did I say that wrong? 32.
Oh.
I said it wrong. 32. On this side, we're going to have 5 subtract 9.31 minus 3. Negative 7.31. Now, really close, but are they identical?
No.
Not quite. Because we rounded, we go on the assumption that, okay, I just made a rounding error and that's correct. But that's what happens with the decimal. When we use our fraction, which is going to be negative 3 over 4, we have to remember our fraction rules. So hopefully you remember them. This is negative 4 over 3, because I'm going to go through it quickly to speed this up. Negative 2 plus, this is negative 4 over 3. Now this is a little more complex because you have to deal with the fractions, but in the end it will be far more accurate. Okay? Minus 3. Okay, first thing, I'm multiplying. When I multiply, I make this a fraction, I go top by top, bottom by the bottom, okay? 3 times negative 4 is negative 12. 3 times 1 is 3. This guy's already over 3, so I'm going to make this 2 over 3, which means, because the 2 can be put over 1, I'll multiply the bottom by 3 and the top by 3. So this fraction becomes minus 6 over 3, and this one becomes minus 4 over 3. Okay, so now I have common denominators, so I can deal with that. All right. Over here, same idea. Let's multiply this first. This is 7 over 1. We do top by top, bottom by bottom. Where you get 7 times negative 4 is negative 28 over 3. Okay. Now this 5 I want to be a fraction over 3 because he's like that. So I multiply top and the bottom by 3. I know I'm going quick here. Does this make sense though?
Mm-hmm.
Okay. And I need this guy to also be over 3 so that we can do that addition and subtraction. So we multiply both those over 3 and that comes negative 9 over 3. Good. Well, because our common denominator is 3, everything's going to be over 3. And we just got to deal with the top numbers. So negative 12 minus 6 minus 4, negative 22 over 3. Okay, that's my left side. On my right side, it's going to be over 3, and we take those values. 15 minus 28 minus 9, negative 22 over 3. On the fraction side, we're identical. Okay, so that's just an idea with the check. That's just a little bit of the checking. Really, the goal was to solve what x was equal to. And if we just checked one of the ways, we were good. But I just want to show you the difference between when we round and we check and when we use a fraction.